This is Algebra 2 with trig, 6b.1. We're going to evaluate logarithms, and we may even find some inverse functions. What we're going to look at first is a logarithm of x with a base of b. This is logarithm base b of x. And that's how you read it. Log base b of x. Now we have these things called common logs and natural logs. So a common log is when we have a base of 10, when we know the base is a 10. So we often don't write that. It's often written as just log. So if we grab a calculator, we can explore with our calculator here a bit. You can see there is a logarithm button next to the 7. This is log. That is a common log. Because if we say the log, remember that would be base 10, because it's not written, it's going to be a 10, it's a small little letter. Base 10 of 10. So 10 to what power equals 10? That's what it's being asked. 10 to the first power equals 10. 10 to what power equals 100? 10 times 10 makes 100, so 10 to the second power. So we can use calculators to do some of our logarithms. Then there's another type of logarithm called a natural log. And that's when we have a base of e. Now you don't usually write it, or you never write it with a lower case of an e here. We write it here in this natural log. We've learned about e. So here on your calculator, next to the 4 is the ln. It's not in, it's ln. It's natural log. So e to what power is going to equal 1? That's an answer everyone can do. E to what exponent makes a value of 1? That's the question. E to the 0 power. Anything to the 0 power is 1. So a logarithm equals the exponent. That's the biggest thing to know. Let's write that down. The logarithm equals the exponent. That's a little better. So if we come down here and we think about rewriting these logarithms, a logarithm equals the exponent. So 5 is the exponent. The base, we all know that the base is the number that has the exponent. Log base 2 of 32 equals 5. So log base 2, so this is 2 to the 5th power equals 32. 7 to what power equals 1? This is giving us all the information. We're not solving for anything. We're just converting it. We're changing it over to exponential form. So some people like to think about this as a little arrow. You start with the 7, start with the base, go to the exponent, finish with the 1. So 7 to the 0 power equals 1. We're just practicing how we can convert a logarithm into an exponential. Therefore, you would know how to take an exponential and convert it over to a logarithm. 13 is your base. Logarithm equals the exponent. So 13 to the first power equals 13. Now notice we don't have a base written. Here we have a 13, a 7, and a 2. We don't have a base written. So if you don't have a base written, that's really just the base of 10. Log base 10 of 10,000 equals 4. So what that is 10 to the fourth power equals 10,000. Now here we have ln. It's not in, it's the natural log. This refers to e. E is the base. E to what power equals 7.39. So natural log of 7.39, that is just about 2. So to write this in exponential form, we know that the base is 2. Let's try that with the e. We can just test our knowledge. E to what power? Logarithm takes the base to the exponent, and that should equal about 7.39. There it is, rounded up. So here we just used a rounded number in the problem, but that's why we got this rounded answer of 2.000. So this is e to the second power is approximately, not exactly, but approximately 7.39. Now it's your turn. Rewrite each of these logarithms into exponential form. I'd encourage you to pause the video, give this a try, talk it over with your partner, see what they think. So we're going to take the base of 3, the exponent of 4 equals 81. 3 to the fourth power equals 81. We wrote the logarithm in exponential form. 8 to what power is going to equal y? That would be the order if we had all these variables in it. We don't have a base. What's the base? If it's not written, that base is automatically a 10. So the base to the fifth power equals 100,000. Base 10, fifth power, 100,000. 10 to 10 times 10 times 10 times 10. Now you can pause the video and take your exponential form and write it as a logarithm. So the main thing I think about is that a logarithm equals the exponent. Log base 7 of 49 equals 2. When we start to get a little farther in understanding, if you can write what you're taking the logarithm of with the same base as a logarithm, can you make 49 have a base of 7? 7 squared is 49. Since these two things are the same, the answer of this logarithm is 2. Now we knew it was 2, but just showing you that there's this relationship we're going to talk more about in the future. That if you can convert what you're taking the logarithm of into a base with an exponent, and these can match, then you're going to know how to evaluate your logarithm. A logarithm with a base, that's what the 3 is, the base. A logarithm always equals the exponent. So logarithm base 3 of 81. And because 81 can be written as 3 to the 4th power, you do know that this is 4. To show you that you can write 81 as 3 to the 4th, when these match, then your logarithm is going to equal 4. So if we were trying to figure out what the x was, this would be log base 5 of 625 equals our exponent. If we didn't know what this equaled, we would try to write 625 as a base of 5. So if we go to our table of powers, and we see our 5 here, that's to the 4th power. 5 to the 4th power is 625. So if we write 5 to the 4th power, these two match, so our logarithm equals, the whole logarithm is going to equal 4. So in this case, x is 4. So that's your first experience with actually solving for an exponent. You could probably mentally do that one. You did it right here. But that's learning how to use the word logarithm in a base and an equal sign. So if we're going to evaluate these, you're going to first write it in exponential form. So you can equal this to x. That often helps. So this is 5 to what power equals 1. You're trying to evaluate and see what this log base 5 of 1 is. So 5 to the 0 power equals 1. We know anything to the 0 power is 1. So this logarithm actually equals 0. Here we have no base written. So it is a base of 10. So we actually have log base 10 of 100 equals our unknown value. What does this equal? How can we evaluate this? Well, different ways to think about it. We can write this logarithm. Well, we're trying to take the log of with the same base as the logarithm itself. 100 is 10 squared. So we know that this is going to be 2. When these match, that's what the logarithm equals. So 10 to the 2nd power equals 100. Here's natural log of 1. Well, we're going to write it in exponential form. So this is going to be e to what power logarithm equals the exponent. So e to what power equals 1? Well, we know that e, or any number to the 0 power, equals 1. So x would have to be 0. So this logarithm would equal 0. This is considered a logarithm. It's a natural log. This one's funny. So this is 49 to the x power equals 7. Now think about what you know about 49. What do you need to do to 49 to get 7? You need to take the square root of 49. What's the exponent that represents square rooting? It would be a half. So this is going to be 2 to what power equals 1 over 32? Well, I know that 2 to the 5th equals 32. So 2 to the negative 5th puts it into the denominator. So my x is going to be negative 5. You can do this with a calculator. We can type log, that's the button next to the 7, and we're doing log, which is a common log, because there's no other base there. Log base 8, or log of 8 is how you read that. It's the common log of 8. And if we round this to the nearest thousandths, tenths, hundredths, thousandths, this is 0.903. This is e to what power? Equals 0.3. So just using our calculator, so natural log, that's next to the 4, 0.3, so that's negative 1.204. And you should be able to test that theory. We should be able to go to e to the x, as we've seen before, right there, next to the 4, but it's the blue. And we're going to have the exponent be our previous answer. Whatever that previous answer is our exponent, so we should get exactly the 0.3. All right, now these are a little weird. Here are some properties. This is log of v is defined only when v is greater than 0. So you can do a logarithm only when you're taking the log of a positive number. You can't do an exponent to make a negative answer. So what you're taking the logarithm of is always going to be positive. Log base 10 is going to be 0. Every time, whenever the logarithm of 1, the answer is 0. And a logarithm of 10 is going to be 1. That's if your bases are going to match, you're always going to have 1. We've talked about, this is a common log. So the base is 10. If those bases match and you have an exponent of k, then we have k. K is what the logarithm equals. And to get really weird, so 10 to an exponent with the logarithm of v, as long as the bases would match, is going to be v. So that's kind of confusing. Let's see it in some written forms here. So here we have a logarithm. Notice the base is not written, so it's a common log. So that means it's a base of 10. These 10s match, so the answer is 6.7. You should be able to try that in a calculator. Calculator is not needed, but you can use it to convince yourself 10 to the logarithm of 6.7, or any number you want to use, and I'm expecting to get the answer of 6.7. This is e. This is the natural log, which means it's a base of e. So our answer is going to be 9. Here's our two bases, the base of the exponential and the base of the logarithm. This is using this rule here, the third rule. that when the bases match, they're using tens here, but it works for any set of bases and exponents, that when you're taking the logarithm that has an exponent and it matches the logarithm's base, then the answer is the exponent. So those match. I guess it's more like this one. It's more like number 4. Alright? Those are 10s of v, so it is v. This is 8s of x, so it is x. Bases match, so our answer is negative 3x. Oh, here's an interesting one. The bases don't match. The base of the exponential and the base of the logarithm aren't matching. Can we make them match? So 2 to the 4th power to the x power. We multiply exponents. Log base 2, 2 to the 4 times x. Now your bases match, and we have an answer of 4x. Logarithms are a crazy language. Good luck, everybody.